Hello everyone. In this video we will solve 2017 question paper for UGC NET Computer Science discipline. And if you want to download the presentation that is used in this video, then you can visit our website www.digimento.com, and over there you can go to the download section. From the download section you can download the presentation PPTs for this video, as well as you can also download the previous year UGC NET question papers. If you want to take the course for UGC NET Computer Science or UGC NET Electronics Science, then you can visit our course section to get the fees details and to take the courses. Or you can also call us on the contact numbers provided above. So without any further delay, let us just start solving the question paper of 2017 UGC NET. I hope that this video will be very helpful for you, and this will help you in your UGC NET exam preparation. For the complete video lectures you can visit our website, and this video is available for each and every one of you. So let us start.
Question number 13 is, which of the following storage classes have global visibility in C or C++? So let's first talk about the storage classes, and then we will discuss the different type of storage classes and their functionality. So what do you understand by storage classes? Let's suppose if you define any variable in a C or C++ language, right? Just like if this is void main and this is integer, let's suppose x. Now you define some variable. So when you define some variable, so the storage class will tell you the scope and the lifetime of variable within a C program. So what is the functionality of a storage class? You can write it down like this. Storage class defines the scope and lifetime of variable within a program, whether it's a C or C++ program. Okay, within a program, whether it is a C or C++ program. Right? Now we have different type of storage classes. First storage classes, let's talk about the different types of storage classes. So the first type is auto, second type is extern or register, third type is static, and the fourth type of storage class is extern. Let's talk about all the storage classes one by one. Right? So this is auto or storage class, register storage class, static storage class, and the extern storage class. Now let's talk about auto storage class. So auto storage class, or you can say the name of this storage class is it is a auto storage class. It is a default storage class for all the local variables. Right? So all the local variables you define in your C program. So by default, if you did not write anything, so by default it is a auto storage class. Okay, and you can see that the second point is it can be only accessed within a block. So it's like if this is int main and there is a one block and you define some variable here, so its scope is here only. So out of the block the scope of this auto class is not there. Okay, so int x can be accessed only in this block only, and if you did not write anything, so by default it is a auto storage class. Now the next one is register. So register storage classes, where we are using this kind of storage classes. Okay, so when you define some variable and you want very quick access to that variable, so in that case what you are going to do, you store that particular variable in the register so that you can easily access, or you can easily in a fast manner you can easily access the variable. In that case we are using the register storage classes. So just write it down. register storage class, register storage class used by those variables, used by those local variables. Write it down, local variables. Okay, this is important. Used by those local variables, those need quick access. Okay, and you can write it down. Then apart from the storage of the variable, all the functionality is same as the auto storage class. So they have same functionality, they follow the same functionality as that of auto storage class. Okay, now the next one is static and external. Now let's talk about the static first. So static storage class. So this class is used to declare the static variable. This is your first point. So those variables which are static, those values are static, not going to change in the entire program. So there we are using this kind of static storage class. So write it down. This class is used to declare static variables. First point. Now the next point is static variables. This be defined in your program. So the static variables have a property of, you can say, of preserving their values even after going out of the scope. Okay, so static means those value will not going to change. So static variables की property है कि वो अगर out of the scope means out of the block, अगर इस block में हमने define किया है static and we define this variable is static, we write it down, static int x. So the scope of this variable, if I talk about this variable in other block, then this here also this value is not going to change, right? So just second point is static variables have a property of preserving their values even after out of scope. Okay, so these kind of static storage class, so they have initialize once, so initialize the value of x once, and until the exist of the entire program the value remains same. The meaning of the statement is this. Okay, and the defined assigned value to the static variable is default value is equal to 0. Okay, initialized. Now the next one is external storage classes. So external storage class is nothing, it is a global variable. So those properties or those features, global variables. So those properties and features of global variables is same in the external storage classes. So once the global variable initialized by some legal value, it you can say declared in some other block and it can be accessed or used in some other block. Okay, so it can be accessed with any function or in any block. The value according to the need it going to overwrite. You can change the value of this global variable in some another block apart from where it is declared. So you can write it down. It can be accessed within any function or block, the value of the global variable, the value of, you can say the value of this variable can be overwritten. So you can change the value of this kind of variable, but in static you are not able to change, as a name suggests the value is static, not going to change. So the question is, now come to the question, which of the following storage classes have global visibility in C and C++? So global visibility is only possible in the external storage class, we already discussed. So the correct answer is option 2, right? And here I'm writing the short note for all the storage classes, because in the exam already 2 or 3 times this question is already came, so that's why I just write it down very short points so that you can easily answer this kind of question, right? Now question number 14 is, which of the following operators cannot be overloaded in C and C++? First one is bitwise right shift assignment, second is address of, third is indirection, and the fourth one is structure reference. So first we talk about the operator overloading, right? So operator overloading, basically it is a concept in which we can give special meaning to an existing operator. Like we have existing operators like plus, minus, equal to, right? So we have this existing operators, but we are giving some special meaning to this existing operators, or you can say it is a specific case of polymorphism, right? So in this like they are the existing operators, right? Now we treated these existing operators as a polymorphism functions. They have different behaviors on the, or you can say they have different behaviors depending on the type of arguments. Okay, so you can say that operator overloading, it is a special case of, polymorphism. Right, in which the existing operators like plus, minus, equal to, or division, right, in which the existing operators treated as polymorphism function, and they have different behavior depending on the type of arguments. Okay, so this is the meaning of operator overloading, कि हमारे पास जो existing operators हैं वो हमारे ऐसा polymorphic functions की तरह behave करेंगे कि अगर we are giving some different type of arguments, so they behave differently, right? Let's suppose if 2 integer values are there and I'm using the existing operator, let's suppose plus, and 5 plus 4 is 9, right? Here this additional operator is behaving like addition of 2 numbers, right? And so the argument in this case is integer. Let's suppose I'm giving the character values. So this is a plus b. So what will be the result? Result is a into b. So here the behavior of this operator is going to be different. So that's why this is operator overloading. So we have different kind of operators. If we specify, or you can say if we categorize the operators according to those who are overloaded or those who are not overloaded. So here I'm writing down those operators who are overloaded, and here I'm writing down those operators which those are not going to be overloaded. Okay, so just write it down, make one note, so that in future if this kind of question will come, so you can easily answer this kind of questions. So the first overloaded operator is arithmetic operators, right? Like plus, minus, division, multiplication, modulus, right? So all these are arithmetic operators. Next one is bitwise operators, like you can say and, or, negations, left shift, right shift. So all are the bitwise operators. Those are overloaded. So this is correct. ये तो overloaded function है, so this is not going to be option. Now the next one is assignment. Assignment. All kinds of assignments are, so all the assignments are overloaded function. Now the next one is relational operations. Relational operations like equal to, not equal to, less than, greater than, so all are the overloaded function. Now the next one is logical, same, and, or, right? Now the next one is compound assignment. Compound assignment, like you can say this kind, right? Plus, equal to, so all kind of these kinds of operators are overloaded. Increment, decrement, so on. So all kinds of these operators are overloaded. Now, but overloaded functions are so many, so my suggestion is just remember the not overloaded function because they are few, and if you remember the not overloaded function, you can easily answer the overloaded functions because rest of the operators are overloaded, right? So conditional operators are not overloaded, so write it down. So conditional operators are not overloaded. Next one is member selection pointers. Member selection pointers are not overloaded. Scope resolution is not going to be overloaded. Size of is not going to be overloaded. Type ID, or you can say object type information, is not going to be overloaded, right? Now come to the question. So which of the following operators cannot be overloaded in C and C++? So bitwise right shift assignment, yes, they are overloaded. Address of, yes, they are overloaded. Now the next one is indirection, yes, these are also overloaded, but the structure reference are not going to be overloaded, so option 4 is the right one. So these are the list of overloaded function and these are the list of not overloaded functions. So just make one quick revision and you can easily solve this type of questions. Now question number 15. If x is a binary number, if x is any binary number which is a power of 2, then the value of x and x minus 1 is what? So they said x is a binary number which is a power of 2. So let's suppose any number which is a power of 2. Let's suppose 8. Let x is equal to 8. Now then x minus 1 is equal to 7. Then the value of x, and if we apply the AND operator in between these two, what will be the answer? So x8, how are we going to represent this in a binary form? So the x value is 8, then 1 0 0 0 in a binary form, and this x minus 1 is 7. And if we apply the AND operation between these two, so 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0, and 1 and 0 is 0. So the answer would be 0 0 0. So the option 2 is the right one. Okay, you can take any value of x and then minus 1, then you get x minus 1, and you apply then AND operations and you finally get the answer. Now question number 16 is an attribute A of data type var character 20. Right, so if A is an attribute and the var character 20 is, it's giving the space, 20 columns are there, like we'll see 1 2 3 4 5 and so on till 20. And the attribute of B of data type character 20, and 20 is is the size of this character 1 2 3 up to 20, right? And the attribute A is taken how much memory space, and the B taken how many memory space. So let's talk about the var char 20. So how it behaves when it going to store the value RAM. Okay, so var char 20 means it's a variable size character. So first write it down. It's a variable size character, right, which can store a character of size 0 and 20, or you can say 0 to at most 20. It can store the size of any character 0 to 20. अगर वैल्यू यहाँ तक लाई करते, then only you are able to store. Okay, if character less than 20, then memory space taken by character, the size according to the size of the value, right? Let's suppose हमारे पास जो हमारे पास space है वो 20 तक available है, तो range is 1 to 20. But अगर 20 से कम है size of your value, then store the value in this RAM, RAM, right? And the rest of the space you can discard. So you can write it down. Memory space taken by character is equal to how much number of character available in your value, in the value. So that much space it going to take. So the space for this is 1, 2, 3. So 3 memory space is taken by attribute A. Now let's talk about the next one, B. So this is a char 20. So it means it is a fixed size character. So what is the property for this, right? So the range is again 1 to 20. So if the value is going to lie in between this, then store the value like Sita. And what about the rest of the blocks? Shall we discard all the blocks? No, we are not going to do that. We are going to pad all the rest of the blocks. So padding should be done in rest of the blocks. And if your value is greater than 20, or you can say greater than the range it already specified, then in that case you are going to skip the rest of the characters. So this is the case. So how much memory is going to take? Complete 20, right? 4 is already taken by your value, and the rest of 16 is going to pad. So this one is 16. So right answer is, it's 20, not 16. 16 bits are 16, or you can 16 blocks are already pad, and 4 is already taken by the value. So 20 is the memory space taken by the B attribute. So 3 and 20 is the right answer. Now the question number 17. Integrity constraints ensure that changes made to the database by authorized user do not result into the loss of data consistency. Which of the following statements are true with respect to the example of integrity constraint? Now the first one is an instructor ID cannot be null provided instructor ID being a primary key. So you know that if some attribute is a primary key, right? So all the primary key values should not be null. So the first condition is cannot be null, right? This is true because अगर ये primary key है तो इसकी सारी values में कोई भी null value नहीं होगी. That's why it's unique. Now the next one is no two citizens have same Aadhaar ID. Yes, if one person has Aadhaar ID, then it should be unique from other person, right? So this is also true. Budget of a company must be 0. So budget of a company is not be null because if your company exists, so it have some budget, right? So this is not true. So A and B is the true and C is the false. Now question number 18. Let M and N be two entities in ER diagram with simple single value attributes. R1 and R2 are two relationship between M and N, right? So M is the one entity and the N is another entity, and there is a relation between these two entities, and the relations are R1 and R2, and it's combined like this. Okay, and you can see that R1 is 1 to many, so write it down, 1 to many, and the R2 is many to many, many to many. The minimum number of tables required to M and N R1 and R2 in the relational model. So this is M, this is N, this one is R1 and this one is R2, and this is 1 to many and this is many to many. You know that in the many to many case, we need the separate table for entity, for all the entities, and for the relationship table, right? So one table is required for this, one table required for this, and one table we required for this. But if we have 1 to many relationship or many to one relationship, in that case we need the separate table for entities, but we merge the relation table where we on the side of many, right? So many side is here, so we are going to merge the table of relation is merged with this table from the many side. So how many tables we require? 1, 2 and 3 tables we required to represent M and R1 R2 in the relation model. So this is 4. And one thing I want to tell you that the detailed explanation is already present in our DBMS lecture. So if you are not aware about this, so just first go through the entire ER diagram chapter and then come back to this question. Okay. Now the question number 19 is, consider a scheme R, a relation N, P and Q are the attributes, and the functional dependencies are like M implies N and P implies Q. So if we decompose this into a different table, that the R1 will contain M and N, and the R2 will contain P and Q, right? Now M and in this case M implies N, and here this is P implies Q. So all the functional dependencies are you can say the preserved. So this is dependency preserving. But for the lossless join, what we are going to see that R1 intersection R2 whether implies R1, right, or R1 intersection R2 whether it you can say implies R2. But here you can see that the intersection of R1 and R2 is going to be null, right? So this is not satisfy the lossless decomposition condition. So that's why it's not a lossless join, but it is a dependency preserving. So option 1 is the correct one. Now the question number 20. The order of a leaf node in a B plus tree is the maximum number of children it can have. Suppose that block size is of 1 kilobyte. So the block size is 1 kilobyte. The child pointer takes 7 bytes long. So the child pointer is, or you can say child pointer, or you can say it block pointer. It's all same. Block pointer value is 7 bytes long, right? So the third parameter is search field value is equal to 14 byte long, and you have to find the order of the leaf node. Order of the leaf node. The order of a leaf node in B plus tree, they define that it is a maximum number of children it can have, right? Now they are talking about the B plus tree, where you know that all the records pointer are present in the leaf node. So the formula is n minus 1 into search key field plus n into block pointers, or you can say child pointers, should be less than or equal to block size, right? So here you can see that if some value is there, right? So the block pointer is 2 in this case. So search key value is n minus 1. If the block pointers are n, means if 2, so 2 minus 1 is 1, like this. And all the record pointers are present in the leaf nodes. So this is the B plus tree. Now n minus 1 into, we don't know the n value, so just keep it n only. So n minus 1 into search key field value is already given, it is 14. Now block pointer value is already given, so this is 7, and the block size is 1 KB. Now just multiply 14n minus 14 plus 7n. Okay, and this is now 1 KB is around 1024, and this will become 21n, and this is less than or equal to 1024. Then this is plus 14, 21n, 1024, and this 14 will become 1038. Now the n value after solving, this is 1038 divided 21, it will become around 49.42. Okay, so n value is the order of the leaf node, the maximum number of children it can have. Its maximum 49 point something, right? Isse zyada it's not allowed. So the order the options are like 16, 63, 64 and 65. You can see that the 63 is greater than from this value, 64 is also greater than this value, 65 is also greater than this value. So the correct option is 16. They're not asking about the what is the value of n. They are asking then what order of the leaf node should be allowed. So it should be, less than or equal to 49.42. So 16 is the answer.